Hello, this is Dr. Toller, and this is part 2 of building an Excel spreadsheet to solve linear programming problems. So if you completed the part 1 exercise, you should have a Excel spreadsheet that looks similar to this that we've used to set up this sample linear programming problem about the 2 different brands of salsa. If not, you should go back to part 1 and set up this spreadsheet before you proceed. So, if you've set up your spreadsheet, it should look similar to this. What I've done is actually typed in different names for the constraints, the whole tomatoes constraint, the tomato sauce, and the tomato paste constraint for the problem. And because I had referenced the cells from the top portion of the spreadsheet, whatever I typed here was transferred into the constraint names down below. So the next thing we want to do is we want to set up this problem in the solver built-in function of Excel. Now, to access the solver program, you should click on the Data tab here at the top, and you should have the solver built-in function displayed here in this ribbon. If you do not see solver here, then you'll have to install the solver add-in. To do that, you want to click on File, and then you want to click on Options in the menu off to the left. Within the Excel Options pop-up menu, you want to click on Add-ins, and then here you want to click on the Solver add-in, and then click Go. This will bring up an add-ins pop-up box, and you just want to make sure that the solver add-in is checked. And after checking that, you can click on OK, and you should see the solver built-in function appear in this Data tab command ribbon. From here, you can click on Solver, and the solver parameters comes up. I'll move it over here so we can see the spreadsheet at the same time. So we want to simply identify the location of our objective function. Click on the icon, highlight the cell containing the objective function, which in my case is G14. Click on the icon again to return, and you want to tell the system if you're maximizing or minimizing or solving for a particular value. In this case, we are maximizing this function, and then next we want to enter the decision variable locations here. And our decision variables are located here, so we simply highlight the 2 cells that contain the decision variable values. In our case, it's H and G and H, 12. Click the icon to return, and then next we have to set up the constraint functions. And I'm going to show you how to add these one at a time, because all of our constraint functions happen to be the same type. We could add them all at once, but I think it's important for you to understand how to add each constraint function one at a time. So we're going to click on Add, and we're going to reference the cell containing the equation. In this case, it's G17. It's a less than or equal to constraint. I'll show you the drop-down menu, which has different options that you can choose from. Ours is a less than or equal to inequality. And again, that's why I originally placed these less than or equal to symbols here, just as a reminder for when I was defining each constraint. And the right side value is identified by clicking on the cell that contains that right side value. And since I'm going to add each constraint value separately, I can click on Add to continue with the next definition. I'm going to move this up a little bit so you can see it better. I'll then identify the left side with a less than or equal to constraint. And I'm going to identify then the right side. We'll add the next constraint value in the same way. And since that's the last one, I'll click OK. So as you can see, I've defined all three of my constraint functions. So the other parameters, we're simply going to check the box that says make unconstrained variables non-negative. So this is how you take care of the non-negativity constraints in a linear programming problem. We don't actually have to put the fact that W and M are greater than or equal to 0, although we could place those constraints here as well if we wanted to. But Excel takes care of that for us by simply saying any unconstrained variables, in this case W and M, are unconstrained, so it will automatically assume that those are greater than or equal to 0. We're going to use the simplex linear programming method, and that's all we need. We're not going to worry about any of the other functions right now. So having defined our model in Solver, we can click Solve, and we get a message saying that Solver found a solution. All constraints and optimality conditions are satisfied, which is good news. So to show you the various reports that are available, I'm going to select all three of the report options, the answer, sensitivity, and limits, and then click OK. And what you'll notice in the tab area is that Solver will create additional tabs that have the report information in them. So as you can notice here, it creates an answer report, a sensitivity report, and a limits report. So we'll go through each one of these separately in a later video. But for now, your assignment is simply to define your linear programming problem in Solver, solve the problem, and then at least take a look at the individual reports. This information is explained in the textbook, so as you go through chapters 8 and 9, it will discuss the various ways to interpret the output from the answer, the sensitivity, and the limits report. And I'll cover that in a separate video. But you have the information, and as you can notice on the sensitivity report, it has final values for W and M of 560 and 240, which was the solution we were looking for. Back to the answer report, you see the final value is that 860 that we were expecting for the value of the maximization. So we have the correct answer when we defined our linear programming problem, which is here. As I said, I created this model from a problem in your textbook where we already knew the answer. We just wanted to make sure we got the same answer as in the text. So use this to solve the linear programming model that you created in the first linear programming assignment.